Hello there, and welcome to lesson number 9 in our series on descriptive geometry. Today we're going to be talking about parallel lines, and I've got some great news for you. I know we've been doing some heady stuff in the previous couple lessons, like 6, 7, and 8. We've been talking a lot about finding lines of intersection and finding planes that are parallel to each other and establishing edge views and then true size and all sorts of crazy stuff. Uh, the next 2 or 3 lessons or so are cake compared to some of the previous lessons we've done. So let's talk about what it means to be parallel. This chapter in your book is filled with a lot of kind of common sense sort of stuff when it comes to parallel lines. Any two lines, if they're on the same plane, if any two lines are contained just within a single plane, like the frontal plane or the horizontal plane, then they are guaranteed to intersect each other or be parallel. It has to be one or the other. They're either parallel to each other or at some point those lines intersect. It may not be shown, it may be very far away from where you're looking at the section of line you may be looking at, but it's one or the other guaranteed. Intersection or parallel. One of the other things that's really great about parallel lines is that if two lines are parallel in space, kind of like how these guys are. Notice how they're not frontal or horizontal or planar or profile lines, but they are parallel in space. And parallelism, it carries over to all of the primary views. So if something is parallel in space, they're parallel in a front view, they're parallel in the profile view, in the horizontal view, and really any auxiliary view you can imagine. Those lines are always parallel to each other. Now, notice that I said if the two lines were parallel in space. That's not always going to be the case, as we're going to see. Now, one of the other important things about lines that are parallel, if you put one line in a point view, the other line is automatically also in a point view. This is great for establishing distance between two lines, like we've been doing when we had those two cylinders and we were trying to find the distance between them. We put one in a point view and measured to the other one. Well, if the two lines are parallel, you put one line in point view, the other line is also going to be in point view. Now, what about the other case where we'll hide this guy. These two lines, they look like they're parallel, and they still look like they're parallel from the profile view. But are they actually parallel? Well, no. If you look at them, they're actually skew lines to each other. So if you have lines that appear to be parallel in primary views, it's not necessarily the case that those lines are automatically parallel all the time. The key is, as I was saying earlier, the lines have to be parallel in space. If they're parallel together, then they're always going to show as parallel. It's if something shows as parallel, it's not necessarily guaranteed that the two things are actually parallel. One of the great ways to tell is to get a point view of one of the lines. Let's do that now. We'll go over here and I'll make a plane that is perpendicular to this line. There we go. There's a plane that is perpendicular to that line, and we will look normal to that. So now you get a point view of that line, but look, the other line is not in a point view, so you can say that those lines are not parallel to each other. Okay, let's take a look at our first example over here. Our job is to complete the front view of the line XY, that's this guy over here, that is parallel to the plane ABC. Now, if you want to find something that's parallel to a plane, we need to get like a non 3D appearance of this plane. We need to get an edge view of this guy. Because if these two things are parallel, and it says that the line XY is parallel to the plane ABC, then it has to be parallel to the edge view of this plane. And that's exactly how we're gonna nail this problem. So I've already drawn the folding line for us right here of the horizontal and frontal views, and I'm going to go ahead and manufacture a true length line for us. So over here, one here, and one there, and then we'll trim away the excess. Which means that this line right here that we've just made is a true length line. So we'll mark it as such. Great. So now if we take a view that is perpendicular to that true length line, we're going to get the plane ABC in edge view. And that's exactly what we want, so I'm going to delete that text, and we're going to move to the folding line layer. Right there. We'll pick this up, and we'll just go this direction, because I don't want to be dragging projection lines across other views, and you can do it, it doesn't look very nice to me. It's hard to understand. And that'll be auxiliary view number 1. We'll switch back to the construction layer, and we're going to need a set of perpendicular. There we go. And then we will copy and go on some pasting madness. There, pick up that one, and that one as well. We'll get everything to the starting line here, right there at the folding line, and then we'll trim away the excess. Alright, everything's ready to go. So this is the view we want to create over here, and we'll do our offsetting from down here. So let's offset and start with A. I'm going to do a zero fillet between these two objects, which basically acts as an intersection. And we'll keep going to B. Use layer make current to put us on the object layer. I'm going to make a little cross right here in the center of the line that's coming up. And delete the excess right there, and we're going to mark that line. Yeah! Move that point out of the way. we'll specify that line to be in an edge view. Alright, that takes care of one object. Let's take care of the line x and y. Now, I don't have a point for y down here. I only have a point for x, so I'm only going to be able to get one little piece here. Now, I know for certain that the point x is located right there. I also know it's on the auxiliary view 1, so I'm going to place it there. Now, because these two objects are parallel in space, they're parallel in every single view, but this is the only one which is really easy for us to draw in. So we're going to place this line so that it's parallel with that plane in edge view. And then what we can do, we know that because of this projection line here, that the point y and this line have to meet up. That's where point y has to be. And now we can sort of play that game in reverse. If we want a view down here, well, we can move two views back and use an offset over here to establish a distance down here. So let's offset from the point y to here, and then from here down. With an extension line from point y. There we go. Puts us on the object layer, and we are basically done. All that remains is a little bit of cleanup. So let's dynamically adjust the length of all these things here. Yeah, interesting. I must have accidentally copied something extra there, so I'm going to delete that. And alright, there we go. We are good. So this line xy is parallel to this plane, and there's the frontal view that we were asked to create. So that's example number 1. Let's go take a look at our second example, which is we want to pass a line through this point K, and we want it to be parallel to both the planes EGJ and MON. Now, here's an assumption I made when I was attempting this problem before I made the video. I assumed that the planes EGJ and MON were parallel with each other, and that K would be parallel to both of them. So, what I did is, I said, well, okay, E to J is parallel, looks like it's parallel with the folding line, so I measured it with the angle tool, and the angle tool's right there. And sure enough, E to J is a true length line. So I took a measurement of, alright, I took another auxiliary view perpendicular to the line E to J, and I put it down here, and I expected EGJ to come out as edge view, which it did, but my problem was that MON did not come out to be perpendicular, or also in edge view. what I'm trying to say is that these two planes are not perpendicular to each other. You can see that in one of my experiments down here. So this guy did indeed come out to be an edge view, but this guy did not come out to be an edge view. And on reflection, of course that's the case. These two lines, these are parallel to each other here, but they're not parallel in this view. And if those two lines were actually parallel in space, and those lines were on those individual planes, and those planes were parallel, they should have been parallel in every view. But that's not true. So this is actually a trick question. If you have two planes, and they're not parallel, as we've sort of logically worked out as the case, then they have to do something. So recall back from the very beginning what we were talking about. If two lines are either parallel or they intersect. And the same is true for planes. They're either parallel or they intersect. So this isn't actually asking about parallel things at all. It's actually asking about the line of intersection. That's the only thing that these two planes share. And if you had a line that was parallel with the line of intersection, then you would also have a line that was parallel with the plane, and it was also parallel with this plane as well. So how are we going to do that? Well, we've got two views. We don't even need this folding line. We're going to use the two-view method and make it work. Step 1. Two edge view planes. There's one. There's another one. Next up, cut through to E to G, G to J, M to N, and the line NO. Trim away the excess, and I'm going to connect each of those lines of intersection. This one right here that's being created by that plane slicing through that horizontal view. Oh, didn't complete that line. There we go. And we'll go again. This time, E to G. To the line M to N, and N to O. Trim away the excess. That's interesting. Left behind a couple little pieces there. I'm not sure what that's about. Now we will let's do our neat little zero radius fillet trick. We'll mark each of those points right there. Ladies and gentlemen, I give you the line of intersection. So now we can take the line of intersection to be, to be parallel in all views. So what we'll do is we will make a line. Do I have parallel turned on? Yeah, I do indeed have parallel turned on. There we go. Parallel. Now, the problem doesn't specify a length, which kind of irritates me about these sorts of problems. Frustrating, but is what it is. And just for thoroughness sake, we'll add a couple of projection lines for our parallel line here. And then after some cleanup, this guy is entirely finished. And that's really all there is to parallel lines. You don't have to overthink it that much. Really, any difficulty that you're going to encounter in these types of problems is really going to come down to wording, the semantics of the wording. If you hear something like the lines are parallel in space, then they're parallel all the time. If you determine that the two planes that you might be working with aren't actually parallel, then there's a line of intersection that is parallel to both of those planes because it's a mutually shared element, a mutually shared boundary in the form of a line. There's a lot of basic intuition in your reading about kind of like your basic logic of A is B, then B is C, A is C also sort of thing. If you have two lines that are on a plane and they intersect, and then that plane is parallel with another plane containing a different two lines, then all four of those lines are parallel to each other, sort of thing. It's very simple. It's weird in the reading, so I would encourage you to talk to your classmates, talk to the teacher, something, if the wording is messing with you a little bit, but the actual procedure is nothing different than what we've been doing. Alright, so that's going to finish it out for lesson number 9 on parallel lines. I'll see you next time.